These are examples for section 6.1, angles and sides of polygons. Example 1. What is the sum of the interior angle measures of a heptagon? A heptagon is a polygon that has 7 sides, so n is equal to 7. N represents the number of sides in any polygon. Then, since we want the sum, we use sigma, Greek letter sigma, is equal to the number of sides minus 2 times 180 degrees. We discussed in our notes that 180 degrees, since it's the sum of all the interior angles of a triangle, that we use that because triangles can be created all through the polygon. Since the number of sides is 7, we substitute in 7 for n. 7 minus 2 times 180 degrees, which gives us 5 times 180 degrees. So the sum of the measures of all the interior angles of a heptagon, when we multiply, we get 900 degrees. So a heptagon has a total of 900 degrees. So if you add all the measure of all these angles up, you get 900 degrees. Example 2. A common housefly called the Musca domestica has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon, and this is a close-up of one of them right here. It's a regular hexagon. Remember, regular means equilateral and equiangular. What is the measure of each interior angle of one hexagonal facet? So, if we're going to find the measure of each angles in this hexagon, regular hexagon, we use the measure of an interior angle of a regular hexagon, m, is equal to the number of sides minus 2 times 180 degrees divided by the number of sides, n. Of course, a hexagon has 6 sides, so n is equal to 6. So we get m is equal to 6 minus 2 times 180 degrees divided by 6. M is equal to 6 minus 2 is 4 times 180 degrees divided by 6. So m is equal to 4 times 180, 720 degrees. Remember, this is the total sum of all the angles in a hexagon, any hexagon. Then when we divide by 6 angles, or 6 sides, we get 120 degrees per angle in a regular hexagon. So each angle measure of the hexagonal eye facet is 120 degrees. Example 3. What is the measure of angle y in pentagon TODAY? Pentagon, meaning 5 sides. We've got 4 of the 5 angles, and we're looking for the measure of angle y. Of course, this is 90 degrees, and then we're given the other 3 angles. So setting up an equation, we can write the measure of angle T plus the measure of angle O plus the measure of angle D plus the measure of angle A plus the measure of angle y equals the sum of all the interior angles in that pentagon, which would be n minus 2 times 180 degrees, where n is equal to 5. So here's the equation. Substituting everything in that we know, we have the measure of angle T is 110 degrees, plus the measure of angle O is 90 degrees, plus the measure of angle D is 120 degrees, plus the measure of angle A is 150 degrees, plus the measure of angle y, which we're looking for, equals n, which is 5, minus 2 times 180 degrees. Combining like terms or adding these numerals here, we get the measure of angle y equals 470 degrees equals 5 minus 2 is 3 times 180 degrees. plus. Then subtracting 470 degrees from both sides. Well, before we do that, we need to multiply. So the measure of angle y plus 470 degrees equals 3 times 180, which is 540. Now, subtracting 470 from both sides, the measure of angle y is 70 degrees. So the measure of this angle right here in this pentagon, of course this is not a regular pentagon, is 70 degrees. Example 4. What is the measure of angle 1, right here, in the regular octagon at the right? This is an octagon, has 8 sides, so n is 8. And this is an exterior angle off of the octagon. Angle 1 is. We discussed in our notes by the Polygon exterior angle sum theorem that no matter what kind of regular polygon you have, you can always take 360 degrees and divide it by the number of sides. Now that's for regular polygons. So in this particular one, remember that the measure of an interior angle plus the measure of an exterior angle in any polygon is always equal to 180 degrees. They're supplementary. Angle 1 here and the angle supplementary to it is the interior angle. They're always 180. So remembering that, we have 360 degrees divided by the number of sides for a regular polygon for the exterior angle. So to do that, we simply substitute in n, which is 8, so 360 degrees divided by 8 gives us 45 degrees. So each exterior angle measure of a regular octagon is 45 degrees. So up here, since an octagon is regular, the interior angles are congruent. That's because it's equiangular. So they're blank. Each of the exterior angles are also congruent. So they're supplementary. According to what we talked about. Example 5. The measure of an exterior angle of a regular polygon is 40 degrees. Find the exact and the approximate perimeter of the regular n-gon, or regular polygon, if the length of one side is 2 times the square root of 2 inches long. So the length S of a side of a polygon, the length is, in this case, 2 times the square root of 2 inches. And we're trying to find, we need to find n first. Remember, this is a regular polygon. So first of all, we try to find, or we find the interior angle measure. To do that, we take the measure of the interior angle plus the measure of an exterior angle, which is 40 degrees, and that equals 180 degrees because they're supplementary. So subtracting 40 from both sides, the measure of an interior angle of this regular polygon is 140 degrees. Now that's the measure of one of the angles. Then we find the number of sides, n. We take m, which is 140 degrees, and it's equal to n minus 2 times 180 degrees divided by n. Then we solve for n. In this equation there's two n's, so the first thing we can do is get rid of the fraction. We can multiply both sides by n. That gives us 140n equals, the n's divide out here, and we're left with n minus 2 times 180 degrees. At this point, we use the distributive property on the right side. We get 140n equals 180 times n is 180n minus 2 times 180 is 360. Then solving for n, we need to add 360 to both, subtract 180 n from both sides, because we need the n's together. And since we have n's on both sides, we get 1 over to the other side. So 140n minus 180n is simply negative 40n. Those go away, and you're left with negative 360. Divide both sides by negative 40, and n is equal to 9. So the number of sides of this regular n-gon is 9. So the n-gon is a 9-gon, and it's regular, so it's a regular nonagon. We stated the type of polygon we found. Now to find the perimeter, we use the formula that was introduced in this lesson. P for perimeter equal ns. N, the number of sides, times s, the length of a side. So perimeter is the number of sides, 9, times s, which is 2 times the square root of 2 inches long. Multiplying these two together, rationals multiply together, we get 18 times the square root of 2 inches. That's the exact perimeter all the way around this regular nonagon. Remember, it has 9 sides, it's regular, and that means it's equiangular and equilateral. We also want the approximation, so in your calculator put in 18 times the square root of 2, round to the nearest tenths place, and you get 25.5 inches. Is an approximation for the perimeter all the way around the regular nonagon.